So we're going to look now at ionic compounds. We're going to look at their formula and how to name them. So we already know that ionic compounds are comprised of ions. And cations are the positively charged ions, and they are usually formed from metals. So for example, Na+, Mg2+. And this is so much the case that metals form cations that whenever we see a metal in a compound, we are going to assume that it is an ionic compound. That's going to be our criteria. Sorry about that. Anions, on the other hand, have a negative charge and are usually formed from nonmetals, such as Cl-, chloride, or O2- oxide. So if you're wondering how do you tell the difference between a metal and a nonmetal, all you have to do is look at the periodic table. Metals are on the left-hand side of the periodic table, and nonmetals are on the right-hand side. And there's a color-coded periodic table in your textbook. All right, so let's take a quick look at how formulas for ionic compounds are determined. The cation, which is usually going to be the metal, always comes first, and the anion comes second. And the ratio of cation to anion is always expressed, so it's the smallest whole number ratio of cation to anion, and such that the overall charge is 0. The charge of the cation must cancel out the charge of the anion. To name an ionic compound, all we do is write the cation name and follow it by the anion name. Now that seems pretty easy, but it can get a little complex, and we've got to be really clear that we understand how to name ions. That is the key. So first, we've got to establish that there are two different types of cations. There are cations that have a variable charge and cations that have a constant charge. So some metals can lose different amounts of electrons and be stable. So for example, iron can lose 2 or 3 electrons to form iron plus 2, iron plus 3. Manganese can lose 2, 3, 4, 5 to become manganese plus 2, manganese plus 3, etc. And lead can lose either 2 or 4 to become lead plus 2 plus 4. And most metals on the periodic table actually have several charges that they can access, that they can be stable at. Now there are some metals that always lose the same number of electrons, and those have what we call a constant charge. So some examples of those are sodium plus 1, magnesium plus 2, potassium plus 1, aluminum plus 3. So the names of cations that have a fixed charge is the same as the name. Okay, sorry about that. So for example, Li plus always has a charge of plus 1. The name of that cation is lithium. Na plus always has a fixed charge, so Na plus has a name of sodium. They have the same name as the element. So how do you know which cations always have a fixed charge? It's going to be really, really important that you know that. And so here they are. It's just a handful of them. Alkali metals, which are the metals in group 1A, or this first column here, all the elements except for hydrogen. These always have a plus 1 charge. They always lose 1 electron. Alkaline earth metals, family 2A, always have a plus 2 charge. These metals are found in the second column of the periodic table. They always lose 2 electrons, so they always have a plus 2 charge. Excuse me. So on the periodic table, it forms a little diagonal: aluminum, zinc, and silver. 3, 2, 1. So First column metals plus 1, second column metals plus 2, 3, 2, 1. You've got to remember that those are the cations whose charges are Now, all other metals have a variable charge. They have at least 2 charges that are stable. And so we named those cations with the charge. However, the charge is expressed as a Roman numeral. So here is a reminder of what the Roman numerals look like. And so, for example, iron plus 2 is called iron 2, where that 2 is a Roman numeral. What does that 2 mean? It means its charge. Iron plus 3 is iron 3, where 3 is expressed as a Roman numeral. What does that 3 mean? It means its charge. Manganese plus 2 is expressed as manganese 2, where 2 is a Roman numeral. What does that 2 mean? Its charge. The reason I'm saying this over and over again is because one of the areas that people get so confused is they think that this number here is how many there are in a formula, and that is not it. This Roman numeral refers only to the charge of the cation. So now you know how to name the cations. We're halfway there to naming ionic compounds.